Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our typedefs, and we're also going to look at a different type of typedef that focusing on an enumerator as well as a structure. And then ultimately, we're going to use that enumerator inside of our structure. This video is part of a larger series of videos focusing on the fundamentals of the C programming language, and this video also assumes that you've taken a look at the first typedef video. Additionally, this video assumes that you have briefly taken a look at the Wikipedia article that focuses on the list of second moments of area, as well as some of the other geometric properties of these cross sections. Now, we aren't going to dig into the geometric properties too deeply in this video, but what you want to make note of is the number of input arguments that are required to calculate certain cross-sectional properties. So for instance, for a filled circular area, you require the radius. And likewise, if you go down for a filled rectangular area, you require both the height and the width, and so on. So take a second to briefly look at this table so that you can appreciate then what we're going to be doing. The second thing that this video assumes that you are familiar with is some of the operators associated with the C programming language. And so far we've used some of these, but we're going to introduce a new one. And in this particular case, we're going to introduce the member access operator. We've so far used in the earlier video the dot notation that would allow for us to access a particular element in a structure, but in this case, what we're going to do is we're going to have the address of a structure, and we want to be able to access a particular element in that structure. Once again, the difference being is that we're going to be getting the address or the pointer to a structure, and we want to be able to reach in and access a particular field in that structure. In the first video, we simply had the structure itself or the variable that associated with that structure, and so we could utilize the dot notation. If you accidentally forget, NetBeans is very forgiving and will actually convert it over for you, but you don't want to rely on that. So let's go ahead and take a look at what we're going to do in this particular video. This assumes that you've got an that you've got a copy of our typedefs _02. You'll notice right off that we've got a different syntax that we want to focus on, and that is the idea of a typedef enum. We'll take a look and we'll see that there's actually a couple of different ways that we can create an enum or an enumerator. But for this video, all you need to do is recognize that a enum is essentially a mapping between a named value, in this case unknown, filled rectangle, hollow rectangle, and so on, and an integer value. And so essentially what this does is this allows for you to not have to keep track of a bunch of integer values that correspond to, in this case, the type of cross-section that we will be calculating the values for. The second structure is a little bit closer to what we saw in our first example. It is essentially an aggregation, if you would, of fields of different data types. We'll focus on the latter ones first because they are some of our primitive data types. In other words, a double and an array of doubles. But we also have a two-dimensional array of characters, which corresponds to an array of strings. So essentially what we have here is we have 4 potential strings with each one of them being 10 characters long. Remember that when you're dealing with strings that you must always have one additional character for the end of string. So we have 9 usable characters plus your end of string. And then the first field in this structure is going to be an enumerator specifying which cross-sectional type we are working with. So once again, take a second before you get started with the code here to make sure and look at those list of second moments of area, and specifically take a look at the 5 different cross sections that we are going to be looking at. Now, what we want to do is we want to go ahead and copy over our two typedefs, and we want to go ahead and include them in our fundamentals driver.c. We want to go ahead and copy over our prototypes and add them to the list of prototypes that we already have, and go ahead and copy over the stubbed in functions. And what we're going to do in this example is we're actually going to build these functions out. Before we get started with that, though, take a second to go ahead and update your main to include the switch for our new demo. We can simply borrow the typedefs underscore 01 switch and function call and change it over to version 2, and then also make sure that you have updated your help. At this point, you can go ahead and build your fundamentals driver, make sure that you at least have working code at this point, and then let's go ahead and take one last look at our structures, just to be sure that we understand what we are trying to do. So the idea here is that, unlike in the first example where we simply just collected the information from the user using a printf and scanf and stored it into a single structure, what we would like to do is, in this example, we'd like to pass a structure to another function to be able to have it updated inside of that function. Perhaps you have a function that will actually do the calculations for the area, the perimeter, x bar, y bar, and so on. And rather than passing multiple different variables, so in this particular case, you would have, depending on which cross section you're looking at, you may have a function that would have to accept 10 input arguments. What we would like to do instead is we would like to just simply pass it a single input argument of a structure, and we'll pass it by reference, which means it'll allow for us to update the structure inside that function. So basically what you'll see here in this example is that structures can become extremely convenient as you start utilizing more complicated data types. So the other thing just to note, once again, is we have our typedef enum that allows for us to handle an unknown cross-section. Basically, it's a way of saying that we can't do a calculation if we don't know what our cross-section is supposed to look like. Filled rectangle, hollow rectangle, the filled circle and hollow circle, and then the filled right rectangle. We will do none of the calculations in this example. Instead, we're going to focus on how do we update our structure inside of a function. So once again, maybe take a copy of this and put this in Notepad or somewhere where you can see it easily, or otherwise what will happen is you'll have to end up scrolling up and down quite a bit. I'm going to go ahead and open up Notepad, and I'm simply going to go ahead and make a copy of both of these just for convenience in Notepad, just so that I can refer to them easier. There are other ways to do this, but once again, it's up to you, whichever way you find more convenient. Now, we're going to go ahead and focus in on our typedefs underscore 02. And the idea being is that we want to call our update struct function, which will accept the address of a structure. And inside of our update struct, we can do something to the structure. And then our second function will simply allow for us to display the structure. Notice that in this case, it does not accept the address because it is not necessary to do any updating inside of the display. The display struct is essentially just a convenience function that will allow for us to have a consistent output regardless of what our cross-sectional type might be. So to begin with, what we want to do is in our typedefs underscore 02, we'll do a quick reminder of how to declare but not initialize a structure. And we'll start off, we have to remember that the name of our structure type is geometric properties, and we're simply going to call this one example underscore 01. And the second one is going to be example underscore 02. And the idea being is that we want to pass our example underscore 1 over to our update struct function. And to do that, we specify the address of our example underscore 01. And we'll do the same now with our example underscore 02. And then ultimately, we would like to display these structures. So we'll display our example 01, and we will display our example underscore 02. Now keep in mind at this point, all we have done is declared them. So that means that each one of the fields essentially contain garbage. In other words, it is uninitialized values in each one of the fields. So for this particular example, the goal is that our update struct will simply initialize each one of the fields. Now for your projects, you may want to do some additional things inside of essentially what would be your update function. Maybe you'll do the calculations for the area, the perimeter, and so on. But in this video, I'm wanting to demonstrate just how you would go about then ultimately updating a structure inside a function. You probably ought to take just a second to go ahead and update the name and the description for your functions as well before we forget. And for the description here, I'm just going to say update a structure by reference and display the fields consistently. All right, so what we want to do now is we want to go ahead and specify which type of structure each one of our examples are supposed to be handling. And so that's where the Wikipedia article comes into play. And so in this example, what we're going to do is we're going to focus on a couple of the enumerated values. And specifically what we're going to do is we're going to focus in on the filled circle and the filled rectangle. So the first thing that I want to do is I want to initialize these values. So for our cross section here, I want to actually, I'll tell you what, we're going to do this afterwards. Let's go ahead and initialize all the values first, and then we'll go back and we will specify the difference between the two. So inside of our update struct, the whole purpose is to initialize all of the values. And then we'll focus on how we can change specific values. So in this case, how would we initialize, for instance, the cross section to indicate that we simply don't know what it is yet? So we specify this by specifying the example variable, and we can use the dot notation, which, as I mentioned earlier, when you are past the address of a structure, should be converted over to this syntax that will allow for us to access the field utilizing the address of the structure. And as I mentioned, NetBeans will conveniently switch it over for you. But if you're not using NetBeans, you'll want to remember to use the dash and then the right arrow syntax. But this will allow for us then to specify that the cross section would be equal to one of our enumerated values. And so you can think of the enumerator as essentially a mapping between a friendly name and an integer value, so that we don't have to keep track of a set of integers to determine which cross section we are working with. And so all we're going to do here is we're going to initialize each one of our fields. We're going to start with the simpler ones. So we'll start with the perimeter. We're going to initialize it to 0. We're going to go ahead and initialize our area equal to 0. We're also going to initialize the IX equal to 0. And we're going to go ahead and initialize then our IY equal to 0, as well as the X bar and the Y bar, which correspond then to the centroid. So there we go. There's our X bar and our Y bar. And now we get to those last two fields that are a little more complicated because they involve multiple values. And remember that our input names is now going to be a two-dimensional array. Specifically, you can think of it as a vector of strings where each row holds an entire string. There are a total of 4 rows for both the input names and the input values. And the idea is that those would be parallel arrays so that you would have the name in one array and the value in the other array. And you have to do that in C because those are different data types. You could also perhaps justifying having a separate structure for this, but we're going to keep this as parallel arrays where the first array holds the name of the field and the second variable, the second input values, then holds the value associated with that name. So what we'd like to be able to do is do something like input names, square brackets 0, and then we would assign then, for instance, a empty string. Now we talked about this in an earlier video that you can't do that with strings. So for strings, what you have to do is you actually have to use the string copy function. If you're not yet familiar with that, I would encourage you to take a second to look at the string copy function. But what this does is this copies then an empty string into the first row of your input names array. We can then go ahead and do the same thing for the second row, for the third row, and lastly, the fourth row. Now, what we can do for the individual values that correspond to these is we can leverage this parallel array for the doubles now, and we'll just simply initialize this to 0. So we want to specify then the 0th row, index 1 row, the index 2 row, and then the index 3 row. So basically what we're going to do here is initialize the parallel arrays that correspond to the name and values. And what do I mean by the name and values? So for example, the radius, and we'll see that we can then provide then a specific value for the radius equal to 1. So that would be an example of this. But at this point then, what this means is that any structure that gets passed to this function will simply get the default values. And so this is a way of initializing your functions without having to write the code over, initializing your structures without having to rewrite that code over and over again, because what happens is we pass the address of a structure. So in this case, we pass the address of example 01 to the function. It updates the address directly. It updates that structure directly by address inside the function. And then when you pass the next address to the next structure, then it will simply do the same. Keep in mind that example underscore 01 and example underscore 02 have different memory addresses because they are different variables. At this point now, we want to come up with a way to differentiate between the two examples. So we want to make something different about them. So in this case, what we're going to do is we're going to go back to the dot notation. So we have our example underscore 01, and maybe that first cross section then would not be unknown, but rather what it would be is a filled circle. And this is where that Wikipedia article comes into play, because now what we want to do is we want to think about then the properties that would be required to calculate the information associated with a filled circle cross section. Specifically, what we will need to do is we will need to update our input names, and we know that we are required to have at least a radius, and specifically for a filled circle, only the radius. So what we'll do now is we will update that input names array and specify then for a circle that we have to provide the radius. And additionally, what we can do now is we can have our example underscore 1, and for our input values, we will simply assign a value of 0. So this will now allow for us to handle a circular cross section with radius 1. For our example underscore 02, let's assume that we have a cross section of a filled rectangle. Now, hopefully at this point you can start to understand the benefits of the enumerator, because essentially I can use these friendly names as opposed to integer values to be able to identify a filled circle and a filled rectangle or the other cross sections. And you'll see in just a minute how that's going to help us. We also want to go ahead and use our string copy function. In this case, we're going to have two fields. So we have our example underscore 01 dot input names. And for the 0th element, we will have the length. And then for the, we'll go ahead and do both of our input names here. So we're going to have our string copy example underscore 01 input names square brackets 1, and the width. And for those two values, then we'll have example underscore 01 and the input value for the 0th element, we'll say maybe is 1, and the input value for the square brackets 1, or the second dimension, is going to be equal to 2. So in this case, what we're doing here is we're handling a rectangular cross section with a length of 1 and a width of 2. Now, remember I said that we ultimately wanted to display this information in a consistent fashion. Well, that's where our display struct function comes into play. And the idea is that regardless of what structure gets passed to it, meaning which instance of our structure gets passed, so in other words, as long as it is a geometric property structure, that we pass it then to our display structure and we get a consistent table. Well, the problem is that our example 01 and our example 02 have a different number of input arguments. So in the example for the filled circle, you have 1, and for the rectangle, the filled rectangle, you have 2. Likewise, for the hollow circle, you're going to have 2, and for the hollow rectangle, you're going to have 4. We would like to only print out rows that have values. And so what we'll do is we'll start off with our display structure. And you'll note that I've already started the table for us, but what we'd like to do is start with the values that are easily identified. In other words, our perimeter. And at this point, then it depends on how you want to line up your values here and how many decimal places you want to display. We're going to stick with the %.4f that we typically use. And at this point, what we want to do is simply print out the value of the perimeter and utilizing our %.4f placeholder. We can do the same thing with the area. %.4f, and example dot area. And at this point, you can probably guess the pattern. So we'll do the ix, and we once again will keep this to %.4f followed by a new line and example ix, and the same for our iy. And then the last two values will be the last two singular values rather will be our x bar %.4f, and it's going to be example dot x bar, and then likewise for our y bar. And just remember now, we should have initialized each one of these values to 0 in our initial or update structure. This would be where you would do the actual calculations. I'm just showing you in this video how to update those values. And also you would likely initialize these values outside of the structure so that, outside of this function, so that way you could have custom behavior for the initialization of your structure or the calculations. But keep in mind that the purpose here is that we want to see how the enumerator can be used to display specifics about a particular instance of our structure. Mainly, what you want to do is focus in on the relationship between the enumerator's value and the number of names and values, or the number of name-value pairs in our structure. So how are we going to do this? Well, it turns out we're going to leverage the value that is stored in our structure at example.cross-section. And if the value stored, or the enum stored at that cross-section, is equal to a certain value, then we will utilize that to determine how many rows are in our parallel arrays. So let's go through a couple of examples of this. We'll start off with the cross-section, the circular cross-section, or the filled circular cross-section. So in other words, if our cross-section is equal to a filled circle, we know that we have only the radius. And there's a couple of ways that you can go about doing this. You can, of course, just simply print out the value using a printf. And what I'm going to do for a guide here is I'm actually going to borrow one of my earlier printf statements, and I'm going to simply print out two values here. One will be a %s for the value stored in the input names array, and the second will be the value stored in the input values array, and that will be an integer value. So once you've got your template set up, you can simply specify then the different fields by saying example underscore, example dot input names, square brackets 0. And then for the second property, we would simply say example dot input values, square brackets 0. All right, so that's fine if you have only the radius or you're dealing with a filled circle. And so what we can do here is an else if, and we will check the cross section and see if the cross section was equal to a filled rectangle. And with a filled rectangle, we have more than one value. And of course, at this point, you could hard code this just like we did before, and you would copy and paste. And so this would be the 0th value, and this would be the 1 value. This would be the 0 value and the index equal to 1 value. And at this point then what it would do is it would print out both the length and the width. But what happens when you start having things like a hollow cross section, specifically a hollow rectangle? And a hollow rectangle will have 4 values. Well, at some point, it doesn't make any sense to hard code. And so if anything, what we would want to do is we could simply set up a loop here, and we'll create a temporary variable. So int index. And for these 4 values, what we can do now is we can simply say for index equals to 0, index less than 4, index plus plus, or if this makes more sense to you, basically my 0 through 3 index. And what we can do now is we can borrow the code that we hard coded, and everywhere we hard coded an integer value, we simply specify our index. And at this point then, what you can do, you can go ahead and handle each one of the different cross sections. So we'll focus in on our example cross section equal to the hollow circle. And our hollow circle also only requires 2 arguments. So at this point, what you can do is you can simply borrow the code and make one change here. And you can do this for each of your cross sections. And so the very last one then that we want to handle is going to be the filled right triangle. And the filled right triangle also only has 2 properties. And at this point, you probably see a number of ways that you could improve your else if structure. As a matter of fact, you could actually combine the filled rectangle, the hollowed circle, and the filled right triangle, because in all 3 cases, they only have 2 values. But the key thing that you want to do is make sure to include an else. And the else simply indicates that there was an unknown cross section. And you can decide then, do you even attempt to print out any values? Decide whether to print out values. And at this point, you could even decide whether to even print out this table, okay? And so once again, a little bit of playing around that we can do here, but hopefully you can see then how we can utilize our enum to be able to control the behavior of displaying our structure. And at this point, what we want to do is go ahead and build it. We'll see if we've got any typos. We do. That's good. Let's see what we've got here. Oh, I did not specify which input value I wanted to assign 1 to. There we go. And at this point, we should be ready to run our second demo. So what we can do is go ahead and clear our console from the last time. A little bit too much MATLAB there. All right, and so what we'll do is we'll run our typedefs 02. And you'll see here that I have two different structure tables. As a matter of fact, we could probably put a new line at the end of that first table. You'll see here that I don't specify which is which. We actually neglected to do something here. We could actually go through and print out which cross section. That would probably make sense here. So for instance, what we can do, how about if we come down here to the table and we'll add one more row in this. We'll actually add the cross-section enum. And we will print that out simply as a %d because it's masquerading as an integer here. And example dot cross section. And then what we can do, you'll see when we build this, you'll see that you don't get a string value, you get an integer value. We got a little bit more cleanup here that we've got to do. And what we can do here inside of our display structure is we can actually give a more friendly description here. How about if we specify something like a printf, and we will specify the cross-section type or friendly name. And then over here, we'll simply just hard code that it is the filled circle. We can do this for each one of our cross sections. So there's a filled rectangle. The hollow rectangle. The hollow circle. And then the filled right triangle. And we might as well go ahead and put a print statement in for the unknown cross section. And we'll go ahead and build it one more time. We still have one more issue that we need to handle. So you'll see that now at least I'm displaying, perhaps not lined up very nicely. We'll get to that in just a second. But we can display the filled circle under the value and the filled rectangle under the value. And what we need to do now is we need to go back. I believe we've got a mistake in our, yes, we do right there. This was inadvertent. You guys probably noticed it when I typed it, but I missed it. I started off by initializing our example 02 to a filled rectangle, or assigning a filled rectangle, and then I inadvertently switched back. This is supposed to be for our second example here. There we go. Please make sure to note here that this is our second example. I believe I was relying a little too heavily on my autocomplete. And now when we come back over here to the console and then we rerun this one more time, you'll see that we have the filled circle has radius 1. The cross-section enum for a filled circle is 3. The cross-section name for a filled rectangle has a cross-section enum of 1. But more importantly here, you'll notice that the length and width are printed out for the filled rectangle, and the radius is printed out for the filled circle. Now, we can come back in a later video and we'll worry about padding this so that we can clean these values up just a little bit, make this table look a little bit more consistent. But we won't worry about padding in this particular example. Hopefully, though, at this point that you can see how you would go about handling the rest of the enumerated values here. And also note here that we have our unknown, our filled rectangle, hollow rectangle, filled circle, hollow circle, and filled right triangle. And what we could do is we could handle each one of those then not only in our display structure, but we can also handle that in our update structure. So for instance, your calculations will be different based on whether it is a filled rectangle or a hollow rectangle versus a filled circle and a hollowed circle, and so on. So hopefully you found this video useful. We will continue to look at structures and how they can be utilized to provide information back from a function. And as always, if you have any questions or comments, don't hesitate to email me. And thank you for watching.